If you've ever tried to pull data off a CNC machine, a robot, or really any piece of shop floor equipment, you know the problem. Every manufacturer has their own proprietary interface, their own protocol, and their own data format. Integrating two different vendors means building two completely different connections from scratch. MTConnect exists to fix that. In this video, we're going to configure and run the MTConnect standard CPPAgent using Docker containers. We'll cover what MTConnect is and how the architecture works, the device model, what the Device.xml defines. We'll take a look at the agent circular buffer so we can better understand what the agent can and can't do. And finally, we will pull and configure our Docker image, mounting our configuration files, and finally verifying a live agent. By the end of this, you'll have a CPPAgent running locally, serving live data over HTTP. This video is presented by Process Robotics. We're the home of MX Interface, the only multi-machine, multi-robot orchestration software built for machine tending first. So what is MTConnect? Well, MTConnect is an open, royalty-free standard for manufacturing equipment connectivity. It solves a historically painful problem. Every machine tool vendor had their own proprietary protocol, so getting data out meant writing custom integrations for every machine, every time. MTConnect fixes this with a common data model and a common communication protocol. Every MTConnect deployment has three main actors. The device is the physical machine. This is a CNC machine, a robot, an extruder, a scale, whatever that might be. It speaks a native protocol. The next component is an adapter. This is still outside the MTConnect standard, and its implementation is completely up to the developer, but this is a piece of software designed to translate the native protocol from the device into a format that the agent can consume. Next, we have the agent. This is the actual MTConnect implementation. This agent features a circular buffer and aggregates data from all of its configured adapters, making it available over REST and HTTP for the inevitable clients. On the other side of the agent, we have clients. These might be dashboards if we want to display machine state, machine status on the shop floor. They might be process control charts if we want to monitor those as they go by. It might be a historian, want to capture and contain this data in a durable fashion for longer term use. The data is read by the adapter from the device, and it is presented to the agent. And then on the other hand, the agent presents the aggregated data from all of its configured adapters. So let's take a look at the device model. The device model defines every data item that a device can publish and can produce. It's organized into components and subcomponents. Each component has its own data items within it. And we can see down here, our device is structured such and has data items within it, but then further it has components. For example, I have a controller component here, but there's other component types within the MTConnect standard. Things like doors and axes are common. If you have a OEM device, you probably won't need to access or won't need to directly edit this devices.xml. If your device has an internal agent, there's absolutely no reason why you would need to edit devices.xml. That's actually only provided by the OEM in the first place. We have seen some devices with MTConnect capability that come with just the adapter and not the agent. So just this piece and not the agent piece. In that case, you need to supply your own agent and configure it to read data from that OEM provided adapter. In that case, you're still going to need to get access to this devices.xml file, and this is going to have to come from your OEM. They're the only ones that know the machine, and they developed it. Now, for the advanced folks out there, if you're doing custom adapter development and custom application development within MTConnect, then the devices.xml file is yours to maintain, and it's your responsibility to maintain it. The data items your adapter reports must be reflected and must be defined in this device's model. Otherwise, the agent doesn't know how to map this at all. Now you can write this devices.xml by hand. It's just an XML file. You could write this in Notepad or Notepad++ or VS Code. You can develop it by hand. If you're looking for a GUI tool, there are a couple out there. Our friends over at Metalogy have a nice piece of software called Meta Studio. It's a Windows application, but it's a more graphical implementation. And you'll be able to output XML and JSON files from that. So there are some tools out there, some GUI tools out there that'll help. Let's take a look at the agent's inner workings a little bit so that we can understand what it is and what it does. So the agent will reach out and connect to all of the adapters that it is configured to connect to. And it will start receiving data from the collective of all of those adapters. And it serializes these data items and these observations into a in-memory buffer. This is configurable in the agent, and we'll go over that in a little bit. But there is a capacity here. So as new observations from any given adapter come in, the agent puts it at the beginning of the buffer, pushing all of the pre-existing data back one sequence. And when the next data item shows up, it does this again. So there's this rolling buffer window. Once a data item observation gets to the end of the buffer and falls off the back end of the buffer, on the left side of the screen here, we've got these sequences are gone. These are beyond the buffer's capacity. They're gone. They're not recoverable. The agent isn't maintaining it anymore. It's like this on purpose. The agent is structured like this for efficiency, speed, and throughput. So this puts some bounds around what the agent itself can do. What we can do is collect real-time monitoring, or maybe short-term history analysis. We might get lucky depending on the application, how many adapters are configured on that agent, and how much data those adapters are producing. We might be able to ask, hey, what happened like a couple minutes ago? Maybe 10 minutes ago, maybe 15 minutes ago, something like that. We're not going to be able to ask it what happened several days ago, especially if our facility has lots of machines with lots of adapters that are producing a high volume of data. This buffer is going to be full 100% of the time, and there's just no way that we're going to be able to hold all of that. If longer term storage is required, a separate component, a separate database historian is going to be required. The reference MTConnect implementation is CPPAgent, a C++ implementation maintained by the MTConnect Institute. The source is on GitHub, and we'll have a link in the description. The CPPAgent repo is already automatically building Docker images and publishing them to the Docker Hub. So getting CPPAgent running on your machine is as simple as pulling the image and running the image with your already developed devices.xml and your agent configuration. Let's take a look at VS Code and take a look at an actual devices.xml and agent configuration before we pull our image and run it. So I've built a little workspace here, and I've made two files, agent.json and devices.xml. The agent.json defines configuration parameters for the agent at runtime. We're going to provide this to our Docker container before launching it so that the agent knows how to configure itself. Some of the important pieces here are the devices key. So this defines where the agent should look for the devices.xml file. In this case, I'm going to be mounting these right next to each other. So this is a relative path right here relative to where I'm going to launch the agent in the container. Check out the GitHub repo for details on any specifics. But we can control the buffer size here. This is the size of that buffer. This is a, as you can see there, 2 to the x. You can control the size of this buffer. We've also defined that this agent should use the 2.6 version 2.6 of MTConnect, and we've got a couple other parameters here that are just specific to our configuration and our needs. The adapters are configured down in the adapters block naturally. I've already got one set up here that we can run in an adapter that will run in a little bit. The format of this file is going to be specific to the actual agent. There are some other agents out there on the market. This is how CPPAgent configures itself. So this is not MTConnect standard. This is just relative to the CPPAgent project and that code base. Devices.xml can get pretty big pretty fast. This document I have here, I've got one pre-written. This is, well, 160 lines long. There's 2 devices represented here, but other more complex devices might show more data. Once comfortable with this format, it's okay to read as a human. We can follow along pretty closely here. So this particular device is a system monitor device. This is an adapter that is just going to get host stats like CPU usage and memory usage of the host machine where this particular adapter is running. Looking through here, we can see that this grabs CPU load, the number of cores, percent memory used, on and on about, some metrics about the host machine. Now, this is just reading, computer stuff, the CPU, the memory usage. That's not too exciting for us. What we're curious about is the actual devices. This is a representative device within our MX interface platform. So this architecture is specific to us, to Process Robotics, to MX interface, and our product. Another device might look different and might be structured differently. This device model is provided to the agent so that it knows which data item IDs it's responsible for publishing and collecting from the adapters. So let's take a look at actually running this thing. We'll open a terminal here. Now to start, let's take a look at Docker. Let's just make sure that we have Docker installed. Okay, that's looking good. We got the help string from Docker. If you don't have Docker installed, you're going to need it. Obviously, if we're going to run Docker containers, stop here, go get Docker installed, and come back. So the first thing we need to do is pull the Docker container. So for this, we just use the command docker pull, and we need the tag for this image, which is on Docker Hub, which I already know is MTConnect/agent. And then we want to put the actual tag for this. In this case, we're just going to pull the latest. Right now, I think we're sitting at 2.6, but they are all version numbered. So if you did need a previous version for any particular reason, you can just put 2.4 in there. You could put 2.0. I don't know how far they go back off the top of my head. Right now, the current release is 2.6. Nonetheless, there is a latest tag. So this will just get us the latest Docker image available on Docker Hub. So we've got this filled out. Let's go ahead and pull this image. Okay. It looks like our image was pulled correctly. So now we've got a Docker image, and now we can verify this by running Docker images. And I have a lot of images here, but we see Docker latest is right here. So we've got our Docker image. So finally, we just need to run our container. We can do this with docker run. And we want to specify a couple of things in here. First off, we want to make this agent available. We want to make it so that we can access it from outside the Docker network with our own browser. So in order to do that, we need to do -p, which is the definition for port, And in this case, we're going to map port 5001 on the host to port 5000 inside the container. By default, it uses 5000. It can be overridden in the agent configuration. We added our port forward, and then we want to add some volume mounts. So we need to mount the Device.xml and the agent configuration into the container so that it's available for the actual agent executable at runtime. So what we're going to do is we are going to map and mount this local folder into the agent container. And I want to mount the config, so I want to mount this folder. And then we use colon, and now we need to define where the path is inside the container to mount this to. I already know, but we need to mount this to /home/agent. By default, this is where the agent is going to look. This is one of the locations the agent is going to look for devices.xml and the agent JSON. And finally, we need to define which container we want to run. So we need to say MTConnect/agent latest. And lastly, we need to give this an actual command to run inside the container. So in this case, we are going to say MTCAgent, that's the name of the executable inside the container. We want to MTCAgent run. And these are just specifics about CPPAgent executable. We need to pass in the agent config. So let's agent.json. It runs immediately. We start to see that the agent is producing some output. At first, it kind of looks scary up here, but it does report that it eventually found the agent.json, and I actually just know that once it gets down to this kind of stuff, we're fully loaded. In this case, we don't have either of the adapters. We don't have the adapter running, so it's going to fail to connect to this every single time. Right? It's going to say connector, connecting to data source at that IP address that we had configured. Connection refused because the adapter is not running. So the agent's fully running here. We can double check this in a browser. You'd need to know your device's IP address. I happen to know this one here in the lab. We want to go to the IP address and then that port that we forwarded. Okay, so I just started our system monitor adapter, and in the browser here we can see that now instead of being unavailable, we actually have some data. So this little Raspberry Pi that's running this currently has a CPU load of 3.5, and if we hit the auto refresh button up here, this page will refresh every 2 seconds or something. And it looks like we're getting some real data there. So CPU load. Look at that. And we can see these sequence numbers increasing too. So that's a good sign. That means that we're adding sequences to the buffer here. Great. So that's the foundation. That's how we run CPPAgent in a Docker container on your machine. Thanks for joining us, and check us out at processrobotics.com and mxinterface.com. We'll see you next time.